Hello everyone, and welcome back to my MATLAB programming tutorial series. Today we're diving into one of the most important ideas in MATLAB, arrays. Arrays let us store and process multiple numbers in a single variable. We'll start with simple one-dimensional arrays, also known as vectors, and then move to two-dimensional arrays, or matrices. By the end of this video, you'll know how to access and modify elements, perform vector operations, and multiply matrices, all with just a few lines of MATLAB code. Let's get started. Let's start simple, with a one-dimensional array, a vector. Imagine we create a vector called A that contains the numbers 10, 20, 30, and 40. When we display it, MATLAB shows exactly those four numbers in a row. Now, let's look at how to access specific elements. In MATLAB, counting starts at 1, not at 0 like in some other languages. If we ask for the first element, MATLAB returns 10. If we ask for the third element, it returns 30. That's how you read data from an array, by using the element's position, also called its index. Now, what if we want to change one of those values? Let's replace the second element, which is 20, with 90. After doing that, the vector becomes 10, 90, 30, 40. So simple, you can change any element just by referring to its position. That's the power of MATLAB's indexing system. It's like editing a specific cell in a spreadsheet, fast and intuitive. Now that we know how to access and modify vectors, let's perform some useful operations. We'll add two vectors together and calculate their dot product. Let's create two vectors, x and y. Vector x has the numbers 1, 2, 3, and 4. Vector y has the numbers 5, 6, 7, and 8. When we add them, MATLAB adds the numbers in matching positions, 1 plus 5, 2 plus 6, and so on. The result is a new vector, 6, 8, 10, 12. That's called element-wise addition. Each position in one vector combines with the same position in the other. Next, the dot product. This operation multiplies matching elements, then adds up the results. So we multiply 1 times 5, 2 times 6, 3 times 7, and 4 times 8. When we add those products, we get 70. In MATLAB, you can calculate this instantly using the dot function. No loops, no manual math. Vector addition and the dot product form the foundation of vector operations in MATLAB, and they appear everywhere in physics, engineering, and data analysis. Now let's move from one-dimensional vectors to two-dimensional arrays, or matrices. We'll learn how to read and modify individual elements, then perform addition and multiplication. Let's create two matrices, A and B. Matrix A has the numbers 1, 2, 3, and 4, arranged in 2 rows and 2 columns. Matrix B has 5, 6, 7, and 8 arranged the same way. When we display them, MATLAB prints both matrices in a nice grid, just like small tables of numbers. Now, let's access a single element. Suppose we want the value from the first row and second column of matrix B. MATLAB shows that it's 6. Let's change that value to 60. After this modification, matrix B now has a first row containing 5 and 60. You can already imagine how this change will affect the calculations. That single large number will make one part of the result much bigger. Next, let's add and multiply the matrices. When we add them, MATLAB adds numbers that share the same row and column. The result, called the matrix sum, looks like this: 6, 62, 10, 12. Then we perform matrix multiplication using the star operator. The result, called the matrix product, is 19, 76, 43, 212. The difference is important. The plus sign adds numbers in matching positions, but the star operator multiplies whole rows by whole columns. For example, the element in the first row and first column is 1 times 5 plus 2 times 7. That's 19. The element in the first row and second column is 1 times 60 plus 2 times 8. That's 76. Just by changing one value in matrix B, the results of multiplication change dramatically. That's how sensitive and dynamic matrix operations can be in MATLAB. Let's quickly review what we learned today. Arrays in MATLAB can be, for example, one-dimensional, called vectors, or two-dimensional, called matrices. You can access and modify any element directly using its position. You can perform arithmetic operations like addition, the dot product, and matrix multiplication easily and efficiently. Arrays are the foundation of MATLAB. They're what make it so powerful for mathematics, science, and engineering. If you found this tutorial helpful, don't forget to like, comment, and subscribe. And ring the bell so you don't miss the next MATLAB lesson. Thanks for watching, and see you next time.